Hello dear students. From this video onwards, we will learn about View Serializable Schedules or View Serializability. In the previous videos, we have seen what is conflict serializable schedule, and from this video onwards, let's understand what is view serializable. Now, the meaning of view serializable can be stated by giving three conditions. Let's read those three conditions. Let's see what we are given first of all. If you want to learn view serializability, then first of all you will have to learn a term called view equivalent. Just see, first we will learn what do you mean by view equivalent schedule. Okay, schedules. And then once we learn what is view equivalent, it will be very easy for us to learn what serializable. Now we say two schedules S1 and S2 are said to be view equivalent. Now these two schedules S1 and S2 are called equivalent, and basically they are called view equivalent if they satisfy following conditions. Just see, there are three conditions that both these schedules S1 and S2 must satisfy. The first one is initial read. Very simple conditions. Okay, what do you mean by initial read is that we are given two schedules, right? S1 and S2. Now if there is a data item A, let's say if there is a data item A and it is getting read in one of the schedules, say S1, okay, and in the schedule S1, suppose T1 is reading that data item A. Just check my words. In schedule S1, suppose T1 is reading the data item A before any other transaction. So T1 reads the data item A before anything like T2 or T3. Then in S2 schedule also, transaction T1 must read A before any transaction. Basically, example will explain you better. Just check this. Now in this schedule S1, observe where we have got two transactions T1 and T2, and in this schedule S2, observe where we have got same transactions T1 and T2. So basically two schedules of the same transaction T1 and T2 are given. Now observe that there is read operation on A here, and who is doing read A first among the two transactions T1 and T2? Among the two transactions from the top of this schedule, read A is first time done by T1 in this schedule. Now let's see schedule S2, which has same transactions T1 and T2. Now you see there is read A operation in T1 again, but who is reading A first in this schedule? Again T1, because you observe in T2 there is no read A operation. So if you see from top, who is reading from the top of this schedule T1 and T2, who is reading A? Initial read we call it as. Initial read of A is done by T1 in this schedule, and initial read of A is done again by T1 in this schedule. So initial read condition is that if T1 reads data A, let's say data A, if T1 reads data A before any other transaction in schedule S1, then T1 only T1 should read data item A before any transaction in schedule S2 also. If this condition is satisfied, only then we say that these two schedules can be, check my words, only then we say that these schedules can be view equivalent, because there are two more conditions. Okay, let's emphasize on this fact, what we are talking about. Now here are the two schedules S1 and S2, and they contain T1 and T2 transactions. Now you can see that these two schedules are just a different arrangement of these statements. For example, there is read A is A plus 10, write A. So there is read A here, A is A plus 10, write A, correct? Then read B is B plus 20, write B, and read B is B plus 20, write B. Same goes with T2. So the point is that these two schedules S1 and S2, see that these two schedules S1 and S2 are basically for transactions T1 and T2. But what's so special about schedule S2 is that S2 is a serial schedule. Just observe. S2 is a serial schedule, isn't it so? Whereas S1 is a concurrent schedule because there is some interleaving of operations. Now we want to know whether S1 is view equivalent with S2. When will be S1 view equivalent with S2 is if initial read of the data item A in S1 matches with the initial read of data item in S2. So let's have a look at this. In schedule S1, who is reading? Who is reading data item A first? Check this schedule from the top here. T1 and T2 both together. Who is reading A? Now there is read A operation here before anything. So T1 is reading A before any other transaction. And in schedule S2, check schedule S2 now. In schedule S2, who is reading A before any other transaction? Yes, T1 itself is reading A. So if we just show that there are two schedules S1 and S2 this way, and let's talk about data item A. Okay, in schedule S1, who is reading A first? T1. And in schedule S2, observe who is reading A first? T1. Okay, but don't forget there is one more data item B. So this should be initial read should be true for every data item. So let's see, is there any read on B? Yes, there is read B. But in this entire schedule, who is reading B first? You can observe that there is read B operation here also, correct? As I am pointing my marker, but read B is done in T1 first. In this schedule S1, T1 reads B before any other transaction. Let's see in schedule S2, who reads B first. In schedule S2, again you see T1 transaction is reading B. Initial read of B is in T1, isn't it so? So we can say that data item B is read first by T1 in schedule S1 and also read first by T1 in schedule S2. So initial reads of A and B are not conflicting in S1 and S2 schedules. So that is what is the meaning of initial read. Okay, I hope you have understood what do you mean by initial read and how it should get satisfied. Now let's see second condition. I said there are three conditions, only then the two schedules will be view equivalent. Now the second condition is updated read. Now what is this simple condition is that observe these two schedules again S1 and S2 which comprises of three transactions T1, T2, T3 as shown T1, T2, T3. Okay. Now updated read means that suppose some transaction Ti is writing some data item A. Okay, writing some data item A, and some transaction Tj is reading that data item A which was updated by Ti. So this is updation, isn't it? Write A means changing the value of A. So this changed value of A which was done by Ti transaction is getting read by Tj. Okay, let's say this is happening in schedule S1. If this is happening in schedule S1, then the same thing should happen in schedule S2. That means in schedule S2 also, Ti is writing A, you will see this operation, and Tj is reading A which was written by Ti. I hope you understand. So as the sentence here shows that in schedule S1, if Ti is reading A which was updated by Tj, okay, so here just the naming convention has been changed a bit, just don't get confused. What it says is suppose this is the transaction Ti, okay, and it is having read A operation, and who had updated this A? Tj had updated this A and Ti is reading it. If this is happening in schedule S1, okay, then the same thing should happen in schedule S2. You should say that some transaction Ti you should see is reading A which was updated by Tj. As you can see in this example, there is a schedule S1 which has three transactions T1, T2, T3, and we have schedule S2 which has three transactions, T1, T2, T3, same transactions. Okay. Now, is the updated read getting satisfied on this? Now, where do you see read in schedule S1? Just observe read first. There is read A here. Okay. So that means T3 is reading the value of A, which was updated by T2, you observe. Actually, A is updated by T1 also. You watch this, isn't it? But after this update, there was a new update getting done by T2. So whose updated value is T3 reading? In T3, the updated value done by T2 is getting read. Okay. Now, is this same happening in schedule S2? If it is happening, then we will say that these two schedules can be view equivalent. Let's see. Where is read A here? Okay, read A. And who has updated this A last time? You can see that T1 had updated the value of A. After that, read A is happening. So T3 is reading the value of A, which was updated by T1. Are you understanding? And here in schedule S1, T3 is again reading A, but it was updated by T2. You can watch that here T2 had updated the value, which is getting read by T3, and here T1 had updated the value, which is getting read by T3. That means the same transaction notation or the same transactions are not updating and reading the value. So updated read is not getting satisfied for this example, schedules S1 and S2. So above schedules cannot be view equivalent, isn't it? I hope you're understanding. Now the last condition is final write. Very simple again. To understand final write, before we read whatever definition is given, now we say that these two schedules, note S1 and S2, these two schedules, okay, will be view equivalent if some data item is getting written by some transaction in S1, and that's the last write on that transaction. If you see from the top of the schedule, after this write A, there is no other write A. So we call this as final write. Final write of, and who is doing final write of A in schedule S1? T3 is doing it, isn't it? T3. If T3 is doing final write on A in S1, then T3 must do final write in S2 also. You can see that there is write A in T3 and this is final write, because after this there is no write operation anywhere. So this is final write. I hope you are understanding. And that is also getting done by T3. The same transactions are doing final write. So this condition of final write is getting satisfied, then this can be view equivalent. But for the schedules to be view equivalent, just notice all the three conditions must be satisfied. Coming back to our previous example, you saw that A and B initial reads were okay. We noted that. What about final write? Let's see. Who is writing A last in schedule S1? You can see that A is getting written last by T2. In schedule S1, in this entire schedule, final write of A is getting done by T2. So I will write that in schedule S1, final write is getting done by T2. Let's say this is for initial read and this is for final write. Final write of A is getting done by T2. And who is writing A last in schedule S2? You can see that A is getting written last. After this, there is no write operation by T2 only. That means the final write in S2 for A is by T2. Okay. So final writes of A in S1 and S2 are okay. What about B? Come back to schedule S1. Write B. The last write on B is at the bottom here. And who is doing this final write? This final write is getting done by T2. Okay. So in schedule S1, the final write is getting done by T2. You can observe that final write of B in schedule S2 is also getting done by transaction T2. So the same transactions are doing final write in both schedule S1 and S2, correct? Of course, there is third condition. Now we have checked only initial read and initial write. Initial read and initial writes are getting satisfied on both data items A and B, but there is third condition, updated read, isn't it? Let's check that also. Is updated read getting satisfied? For that, what you will have to do is you will have to see read operations. Just check this very carefully. There is read A here, okay, but this is first read, isn't it? What is updated read? Remember, if write is followed by read, then only we will have to check that which transaction has written and which transaction has read. But this is very first initial read, so we don't have to bother about this. Let's see, where is another read? Okay, I'm underlining this. T2 is reading the value of A, okay, but who has written this value of A last time? Check this. T1 had written the value of A, which is getting read by T2. So in schedule S1, T1 writes A and T2 reads that A. Then same thing should happen in S2. In S2, you can watch. T1 writes A, correct? T1 writes A here. And the same thing, I mean, the read operation on A is getting done by T2 here. I hope you're understanding. Because after this write A, there is no write A down below there. So who is writing A in schedule S2? T1. And who is reading that updated value? T2. So the directions are maintained here, T1 to T2. Let's see other read operation. Here is read again, read B, correct? But before this read B, there is no write B. Listen, updated read is only to be seen if somebody has written B and after that you are reading B. So anyway, before this read B, there is no write B. So no trouble. Just ignore this. But there is read B here, isn't it? But whose value is this B getting read? See, T1 had written B here, which is getting read by T2. Okay. So T1 writes B and T2 reads B. The same thing should happen in schedule S2 also. Yes. Check that T1 writes B. Before this, there is no write. So don't worry. And this updated value of B is getting read by T2. Is getting read by this transaction T2 here. That means the updated read operations are also getting, second condition that we saw is also getting satisfied. Initial read, final write and updated read, all three conditions are getting satisfied. Then we can say that these two schedules are view equivalent. View equivalent. And you can see that this schedule S1 is equivalent to this schedule, isn't it? Yeah, it is equivalent, view equivalent to this schedule S2. But schedule S2 is a serial schedule. Please understand this now. I repeat, schedule S1 is view equivalent to schedule S2. But which kind of schedule is S2? Serial schedule. Now, whenever any schedule is view equivalent to a serial schedule, then we say that the schedule is view serializable. Come again, I'll better write that. S1 is view equivalent, correct? I'll write in short, view equivalent to S2. But you know S2 is serial schedule. So this schedule S1, which is concurrent schedule, of course, this is a concurrent schedule because there is interleaving. It is view equivalent to a serial schedule. Then we say S1 is view serializable. So if you are asked, what do you mean by view serializable schedule? Your answer should be that schedule should be view serializable to some serial schedule. If it is view equivalent, view equivalent to some serial schedule, then that schedule S1 is called view serializable. I hope you have understood all three conditions and you have also understood a very important term called what do you mean by view serializable schedule. Okay. In next videos, we will take more such examples and try to find out whether a given schedule is view serializable or not. Thank you very much.